Desmos Day. Today's going to be a little more traditional. Working through your notes packet, so hopefully you're okay with the variety there. We'll see. Mason, you okay?
Yeah.
Okay.
Okay, big dog.
Okay, so we're going to be working on here for the next 3 or 4 days is basically taking all that you guys learned about multiplication and reversing it. And yesterday was kind of the start of that. So today's topic is called factoring quadratics. And quadratic, of course, is sort of a scary sounding, very mathy kind of word. And so I thought it would be worthwhile for us to talk about what is a quadratic. So I'm going to define it for you here by giving you kind of a general form. This is a quadratic. It's got 3 terms, ax squared plus bx plus c. This is what we call a quadratic. Okay, so by way of review, what's the degree of a quadratic? 2. Right? Highest exponent's 2. What would be the lead coefficient of that quadratic? A. That's right. A would be some number. So some other examples of quadratics would be, 5x squared minus 8x plus 13, let's say. So in that case, what's the degree of that particular quadratic?
2.
It's 2. No, it's 2. What's the lead coefficient?
5.
Correct. Here's another example. I'll put this in red. Negative 9x squared plus 3x plus 217. What's the degree of that quadratic?
2.
They're all 2, aren't they?
Yep.
If it's second degree, we can call it a quadratic. Okay. What's the lead coefficient? Just negative 9. It's just that numerical coefficient there. Did you notice that all 3 of these were written in descending order? Descending order is really important. I'll give you another example or two here. So if you had something like this, 5x minus 9 plus 4x squared, is that a quadratic?
Yes.
It is. It's definitely a quadratic. What's the degree? And that's your big hint that it's quadratic degree 2. But isn't it totally out of order? What's the lead coefficient for this one? It's 4, right? So I would want to probably rewrite this as 4x squared plus 5x minus 9. Last one I want to show you here on the what is a quadratic front would be something like this. 16x squared minus 25. So is that a quadratic?
No.
It actually is.
What? Oh, because it's got the 2.
What's the degree?
2.
So that tells you it's quadratic. What's the lead coefficient?
16.
But what's missing? Something's not there.
Like a 3x or something.
A 3x or a negative 8x or something, right? So would it be fair to say that the b term is missing? The b is missing. So what do you think the b is here? 0. Because isn't 0 times x 0? We probably wouldn't write that, would we? We wouldn't write 16x squared plus 0 minus 25. We'd leave the plus 0 off, wouldn't we? So this is a quadratic. We'll come back to that one at a later time. And by the way, have you guys seen anything like this recently?
Yeah.
Where did you see these?
Yesterday in the video.
Say it one more time.
Yesterday?
You did yesterday in the video, but can you go back a little further? What were we doing when we saw these before, even before the video yesterday? What about polynomials? We were multiplying the polynomial. So let me just give you a brief, you don't need to write this down. Let me just give you a brief reminder of what we've been doing. So haven't we done stuff like this, maybe where it's like x plus 2 times x minus 5? And you remember what we used to help us with that? We used a box. So we did x plus 2, x minus 5, and we did x times x is x squared. This would be 2x. This would be minus 5x. This would be minus 10. And you remember how then we added our like terms and we got x squared minus 3x minus 10? Doesn't this look a lot like a quadratic? So you've actually done quadratics before, because when you multiplied your polynomials, like Sasha said. So what we're going to be doing here, so let me put it like this. Before, would it be fair to say that we did this process, like we went from here and then to here? Like that's the process that we did? Guess what we're going to do now?
Reverse it.
We're going to reverse it. We're going to start here and end up back there. We're just going to go on the purple path, right? Instead of the green path, we reverse it and go on the purple path. So guess what we might use? Guess what we might use to help us get organized?
Box.
A box. Yes.
A box.
Yep. All right, so here we go. Why don't I show you how this works? And hopefully we'll get lots of practice here today before we do any quizzy stuff. Hey guys, if we get to 25 after, right now it's 11:06. So if we get to 25 after and I haven't said, hey, let's do your quiz, somebody remind me. It just means I got into these quadratics too much and I forgot. So here we go. I'm going to leave that up there for now. Take a look at our first example. X squared plus 7x plus 10, clearly a quadratic. Let's identify the A, the B, and the C. So what do you guys think? I'll go backwards. What do you guys think the C is? C is 10. How about the B? What about the A? So this is where people will tend to make mistakes. Like, no problem here. This is obvious. You're like, yep, 7 matches up with the B. I'll just write this here, ax squared plus bx plus c. But then they look at that x squared and they say, well, what's the a? Well, the a must be x squared. The a and the b and the c, they will always be numbers. But there's no number there, so it's what? It's 1, right? Technically, it's 1x squared. So c is 10, b is 7, a is 1. A is 1. Does that make sense? 1x squared versus x squared. It's really the same thing. So let me give you this brief process. Hopefully this will work out really good for you because you did great with what we did yesterday through the video. So here's your first step. I want you guys to find what a times c is. So for this one, what's my AC? It's 10. Isn't it 1 times 10? Which is 10.
But isn't it 1x, 10x squared? 'Cause
No, so A is just 1. A is not 1x squared. A is just 1. Just like B is not 7x. Where are we at? Are you with me or are you not with me?
medium.
Oh, I'm really confused.
What are you confused about?
That AC equals 1 times 10.
So up here we identified, or maybe we didn't identify. Do you see how C is 10?
Mm-hmm.
So I did A times C, I did something times 10.
Mm-hmm.
And then we identified A is 1.
Oh.
So I did 1 times 10. Chase, what are you thinking?
I just don't remember doing the ABC stuff like the video yesterday.
We didn't.
Yeah.
What we're about to do, like the way we finish this, is just like the video.
Oh, okay.
Like the greatest common factor thing.
Yeah.
Yeah. We'll finish with that. This part is new, though.
All right.
You shouldn't remember this
Okay. All right.
because
Yeah,
you
that-
probably have never done this
yeah,
before.
that was confusing.
Okay. So are you okay? Are you okay with A being 1? Are you okay with B being 7? This is where you say yes or maybe no, I'm not okay with that. I have a question.
Why is the x squared or the x not the one?
So basically it's about defining what it is that we're looking for. So A is the numerical coefficient. So A is a number. Like it's a numerical value. It's not a variable. It's the coefficient, the numerical coefficient being multiplied times x squared. Like, so think about it like this. If I said, hey, I would like to see Mason's watch. Let's say you were wearing a watch and I said, I'd like to see Mason's watch. Wouldn't you take your watch off and give it to me?
Yeah, I understand. I got it.
So like we're removing the numerical coefficient off just like you're removing your watch off, your arm. How we stand? This is crucial. Like if something's confusing here, we got to get it fixed right now because the rest of this is going to be completely meaningless if we don't get this part. We doing okay with A being 1, B being 7, C being 10? Okay. With that in place, are we okay with A times C being 1 times 10,
Yeah.
which is 10? Are we okay with this? Okay.
Wait, 1 times 10 is 10? I'm just kidding.
All right. So then there are a number of ways to approach this. Here is a way that a lot of people like. I'm just going to show you a little graphic here. You don't have to do this. You could just do this in your head if you want, if you can. A lot of people like this little X graphic. And here's what we do. We put the AC, that 10 that we just figured out, goes here. The B, which is 7, goes right there. And here's what you've got to do. And you could use your calculator for this. There's a number of ways to do this. You've got to figure out which numbers, any numbers you can think of, that multiply to be a 10 and at the same time add to be a 7. So here's what you might do in your head.
5 and 2.
So, yeah, so sometimes people come up with these super quick. Here's what you might do in your head. You might say 10 times 1. Well, what's 10 plus 1?
11.
Doesn't match up to 7, does it? So that's out. All right. How about 5 times 2? That's the only other possibility, right? 5 times 2 is 10. Is 5 plus 2 7? It is. So you're going to want to think which numbers multiply to be 10 and add to be 7, and you'll put those numbers here and here sometimes. Like I said, you don't really have to do this little X thing. But for some people it helps just like go 10, 7. Add to this, multiply to be that. We just got to come up with those two numbers. And then here's our final step. In Chase, this is where we connect back with yesterday. I'm going to build my box. Here's how I do it. The x squared always goes upper left. And the C, the 10 in this case, goes lower right. And then the 5 and the 2. So the 5 and the 2 come into play here. We write 5x and 2x. So this is really hinging on you remembering the thing that Sasha said. Do you remember when we multiplied polynomials using a box?
I don't do box. I'm just gonna multiply them.
Okay, well, so then when you multiply, sometimes people use that FOIL thing.
What do you mean FOIL?
FOIL, yeah. How do you multiply then?
Just like multiply the first one by that. And
So you're doing some distributive property stuff? Those two middle terms always end up with an x. Like, it's not because okay, Mason, I'll show you. So if we do this, watch. Please watch carefully. X times x, Mason, is x squared, right? X times 5 is not 5, it's?
5x.
There's your 5x, right? Multiply these here, you get negative 9x. Multiply here, you get negative 45. Do you see how these two middle terms always have an x attached to them?
Yeah.
That's why it's 2x and 5x, because it's always there.
Why is that 2x? Isn't that 4x? Because it's negative 9.
I made up a different question just to show you a different example. Just to show you a different example. I don't want you to think that every single number is 2 and 5. Okay. And maybe, Mason, I can prove this to you a little bit better at the end. So check this out. So this is where we look for our GCFs. What I'm going to do is I'm going to factor. I'm going to factor vertically. So between 5x and 10, what's the greatest common factor? Say it. 5 is the greatest common factor. They both have a factor of 5. Okay, how about here? What's the greatest common factor? Sorry?
2, 1,
What do they both have?
x.
Don't they both have an x?
Yeah.
You guys with me? This is just like the video. I've got an x times x and I've got a 2 times x. They both have an x. So that's my GCF. And then I factor from right to left along here. What's in common between x squared and 5x? Correct. What's in common between 10 and 2x? 2 is correct. So then does this not look just like the multiplication we've done a bunch? So what we've done is we've broken it back apart, and my factors would be x plus 5 times x plus 2. I'm getting those from here and here. So I would like to maybe prove this to you through checking. So check this out. Here's what we used to do in the past. We used to start off with this. So Mason, this is where I'm going to try to hit home with you because you were questioning the 2x and the 5x, so make sure you're paying attention. Didn't we use a box to multiply these? So I'm going to just put in my little box marks here, and we did x plus 5, x plus 2. And didn't we just multiply to fill in all the little squares in the box? So x times x is? X squared. X times 5 is? X times 2.
2x.
And 5 times 2 is? Do you see how that box is exactly the same as my other box?
Yeah.
And so what we would do here, of course, to finish this is what we did in the past. We'd say x squared. Those two terms are like terms. So 7x plus 10. I'm done. So if you do these right, you almost won't be able to tell if someone multiplied or factored, because they should look the same. I mean, if you look at some of the other details, you'll be able to tell. But if all you looked at was the boxes, it should look the same as what we did before. Mason.
I just don't understand like what we're doing.
So here's what we're doing. Here's what, like,
No, but like
okay.
the answer we got is already up there. Like it's x squared plus 7x.
No.
That's what we got.
No, Mason. Mason, I'm over here. Mason. So this right here, I'm putting a black circle around this. This was simply me checking my answer and proving to you that this works. The stuff that I'm putting in a neon green box, this is what we're doing. So if you want it in a nutshell, what we did a couple weeks ago is the stuff in the black circle. We multiplied polynomials.
Yeah.
No, Mason, let me finish my explanation. In the green box, isn't x squared plus 7x plus 10, isn't that the result of what we were doing in the past? Like that was like an answer to one of those questions?
Yeah.
So what are we doing now? What we're doing is we're taking that multiplication that we got good at in the past and we're reversing it. We're trying to undo it. So you could pretend this if you wanted to. You could pretend that somebody came before you and they multiplied some polynomials and they got the answer in the blue box. Now your job is to break that back apart.
X plus 5 and multiplied by x plus 2.
Say one more time.
The answer is x plus 5 multiplied by x plus 2.
This would be your answer. Yep, we've factored it. We've taken it from something that had been multiplied together and we reversed it to what it began with. We're taking all those polynomial multiplications you did and we're trying to break them back apart. Yes, ma'am.
So my question is kind of at the start. When we multiplied the A and the C, does it always have to be A and C? Or
Yes.
Can it be like A and B?
No. Every time A and C. So the method, by the way, the method I'm going to teach you is very consistent. If you were to look in your book, or maybe even some other books, or even if you were to look online, now listen now. If you were to look online, you might see that some places might say, hey, in this case, use this method, and in this other case, use a totally different method. I'm not a fan of that. That leads to confusion. I'd rather just say, hey, if you have a quadratic, here's how you factor it. Period. Just one consistent way. And this way will be very consistent. It'll work fine. Maybe it might help you guys to see a little bit of a broader perspective. So check this one out. Please, check this one out. Number 2. By the way, this is all going on video. So, and you guys are asking great questions. So if you're working on your homework later on and you thought, oh man, factoring it, just watch the video. It's all there. I'm happy to help you, but if you're by yourself at your house, it might not work that great. I won't be there. So, you guys recognize that this is a quadratic. And the instructions say factor. So again, please listen. Don't be distracted. Factoring means to take something that somebody came before you and they multiplied some polynomials together. Factoring means take their answer and break it back apart. Break it back into a multiplication problem. Are you with me? Okay. So, we're going to factor this. Here are your steps. Number 1, identify the A and the C. So what's our A value?
2.
And what's our C value?
5.
So 2 times 5. Our A times C would be 2 times 5,
10.
which this is a coincidence. It happens to be the same as the other one, right? It's just a 10. They're not all going to be 10. This one happens to be 10 as well. And then what we do is we take the 10, and if you want to put it in a little x, that's fine. What do we put in the bottom of the x? It's the b, right? It's 11. Here's where you got to think, which numbers multiply to be a 10, but then at the same time add to be an 11? It's a 10 and a 1, right? 10 times 1 is 10.
I didn't even think of that.
That's the one that people often forget. They're like, no, 2 times 5 and all,
You're brilliant.
So 10 times 1 is 10. 10 plus 1 is 11. So here we go. Hey guys, listen up, please. We build a box. Here's how the box works. What goes in the upper left-hand corner? The whole term. Like ax squared, right? The whole thing. So in this case, it would be 2x squared. What goes in the lower right?
11x.
Nope. Nope. 5 goes in the lower right. Somebody just said why, I think, Noah. It's just like the multiplication we did, right? Okay. And then what goes in the other two boxes? 10x and 1x.
Why do you have to add the x?
Mason, it's the reason that I explained to you before. When you multiply these back out, don't the two middle terms end up with an x?
Oh, yeah. But then, like, so you just have to.
You just got to remember that they both have x's, right? Because I'm really relying on the fact that you know how to multiply polynomials to do this. Okay. So now, what we need to do is we need to factor along the orange line. Of course, yeah.
Doesn't matter what side, what corners the 1 and the 10.
Great question. It doesn't matter where you put the 10x and the 1x. You can flip them diagonally and you'll get the same answer. It might feel a little bit different if you compared, but in the end it'll be the same. All right, what's the GCF between 10x and 5? 5. They both have a factor of 5. Okay, how about the GCF between 2x squared and 1x? There's a common x and that's it, right? And then if I factor along the purple, what's the GCF there? There's a 2 and an x, right? They both have an x in common, and 2 does go into 10, so 2x. And then what about along the 1x plus 5? Only a 1 in common, right? So I'd put a 1 right there. So my final factoring would be x plus 5 times 2x plus 1. If you wanted to check this, couldn't you just take those two binomials and multiply them back together?
Yep.
Should end up with who you started with.
All right.
Got time for one more.
This is 25.
So number 3, let's do number 3 for sure. Yeah, this one will work out great. Okay, it's a quadratic in descending order. What is my C value?
-18.
Negative 18. What's my B value? Negative 3. What's my A value? A is 1. Okay, so A times C is 1 times negative 18, which is negative 18. So now what I do is I make my little x, put the negative 18 there. What goes in the
3x.
lower part?
No, just 3. Just 3.
You got to keep the sign in front. It's negative 3 is what we'd put there. Just negative 3. I'm just trying to work the numbers out here in my little x. I'm going to try to figure out which numbers multiply to be negative 18 and add to be negative 3. This is a little bit tougher than the 10, right? So can you think, which numbers multiply to be, what is it? 6 and negative 3? That's close. What's 6 times negative 3? Perfect. What's 6 plus negative 3?
3.
6 plus negative 3 is 3, but it should be negative 3, so what do we need to do, Isa?
Negative 6 times 3.
There we go. Flip the signs around. So it'd be negative 6 times 3. So you might find some times when you accidentally flip the signs around, just fix them and you're in good shape. Now I need to make my box. So, Trevor, in my box, what goes upper left?
The A.
Shh. Yep, upper left is always going to be your lead term there, so x squared. Ella, how about lower right? Yeah, it's always the C, goes lower right. Mason, what should I put in the other two boxes?
3 negative 6.
Close. 3x and
Negative 6.
negative 6x. There we go. And the order doesn't matter. If you flip the negative 6x and the 3x, you'll get the right answer regardless. Okay, what is the GCF along the purple?
3.
It's 3. That's right. What is the GCF along the green? Don't they also have an X, though? They both have an X. We're going to, the last one is going to have just a little bit of a trick to it, but not this one, though. What about along the red? What's in common?
X.
That's correct. Now, this last one is a little tricky. I'll color it in orange. What's tricky about this is it's either 6 or negative 6, right? So, guys, listen, this would be one of those moments where if you're listening, it's going to be super easy. If you're not, you're going to be like, well, you never said. What I'm doing is I'm factoring from right to left. I'm factoring from right to left. So I'm putting some arrows in here. If the box you finish with is negative, then you factor out a negative. So notice how it's negative 6x is the box I finish with. So if the box you finish with is negative, you factor out a negative as well, so it'd be minus 6. So my final factoring would be x plus 3 times x minus 6. Yes, ma'am.
So if you would switch negative 6 back
Yep.
around, you could
Look at
just
that.
put it
Same
that
thing
way.
I got.
Okay,
Yep.
So it doesn't matter.
It doesn't matter. Doesn't matter at all.
What time did
Great
you say
question.
you had to do the test?
Right now. Okay, if you guys would, please clear your desks off, get a fort going, and we'll get started with your quiz.
Hey, if I can, congratulations.